Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Rat Run 21 Friendly by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Aim of experiment. Finks and Finks must both reach the cupcakes by finding a path through the maze. The paths must not visit any cell more than once, cross themselves or each other, or pass through any thick maze walls. The paths may not share cells except for where they meet at the cupcake cell. So basically, Finks and Finks must form a path to the cupcakes, and they cannot cross each other. They cannot visit any cell more than once. They cannot pass through any thick maze walls, and they may not share cell. The paths may not share cells except where they meet at the cupcake cell. As well as moving orthogonally, Finks and Finks may move diagonally if there is a 2x2 space in which to do so, but may never pass diagonally through round wall spots on the corners of a cell. So, for example, I think this is Finks. Finks. Wait, what? Finks, and there's Finks. So Finks, I think, is this one. But this Finks could actually go diagonally here because this 2x2 space is available. And so is this. But it cannot go diagonally here because it would be going through a rounded wall spot. And the rats can also move horizontally and vertically, so that's perfectly fine also. We have black courants, where if two digits are joined by a black courant, one is double the other. So these are also known as black Kropke dots. So for example, if this were, say, a 2, this would have to be 1 or 4 to make sure that one is double the other. We also have grapes, which are these green dots. If two digits are joined by a grape, they have a difference of at least 5. So, for example, say this was a 3. That would mean this has to be 8 or 9, because those are the only digits which are 5 or more away from 3. We have forbidden doors, where if two digits are joined by a red X, they sum to 10, and Finks and Finks may not pass directly through a red X. So therefore, these rats cannot go this way through the X, for example. And they add up to 10. So for example, if this were, say, a 3, this would have to be 7 because the digits, they have an X in between them. Therefore, they must add up to 10. Okay, the test constraints. In this experiment, a cell may only be visited by Finks or Finks if its digit matches its row number, its column number, or its box number. And boxes are numbered 1 to 9 in normal reading order from top left to bottom right. So this is basically box 1, box 2, box 3, box 4, 5, 6, 7, 8, 9. And the test constraint, so this, say we had a 3 here and a 9 here and a 3 here and a 7 here. The rats could go through this cell because the 3 matches the row number and the box number. So it has to match just one of those for the rats to be able to go through that cell. Or maybe visited, shall we say, by the... So This 9 also works because it matches the column number of the cell, right? This is the column 9. This 3, though, could not be visited by any rat because it's row 4, column 4, and box 5. This 7 also could not be visited by any rats because it's row 5, column 4, and box 5. So those are examples of how test constraints work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so these must match a row, column, and or box number to be able to go correctly. Because it is on the path. So therefore, thinks this is row 1, column 1, and box 1. So it must match the cell, so this must be a 1. This is row 9, column 1, and box 7. So this is 7 or 9 here in the cell for the rat. This cell is also on the path, and it's row 5, column 9, and box 6. So this is 5, 6, or 9 here. Can you go through this path? So there are, I guess, there are 4 entrances into the cupcakes. You have to go through this path, here, here, or here, right? This acts like a wall, so therefore that's not possible to go through. To go through this spot is interesting. So you can't go diagonal through any of this. It'd have to be through these. You could do it if it's column or box in one of them. So if this were to be correct, you could go, this would match column 7, box 3. Obviously cannot be row 1 because we have a 1 already in the row. Box 3, column 8, 3, and 9. This could match column 9, box 3, or row 2. 2, 3, or 8 here. And this would have to be row 3, column 8, or box 3. So no, you cannot enter this way through the because this would form a 2, 3, 8, and 9 quadruplet in 5 boxes, which is not allowed. Right? These cells can only contain 2, 3, 8, and 9 if we go this path through. So none of these can be on the path, because to get through here, you have to just continue all the way through. So this is not valid to go through this path. So that's not possible. That means it has to go through here, or through here. Okay. What are the remaining digits? Well, let's do these. The remaining digits here can be 1, 2, 3, 4, 6, and 8 next to a black Kropke dot. Because 5, 7, and 9 cannot be next to them, because 5, 7, and 9 have become 2.5, 4, 3.5, and 4.5, which are not digits. If you double them, you get 10, 14, and 18, which are not digits. So can this match? This can't be 1. This matches row and column, potentially. But this Finks doesn't have to go through there. Finks can go through some weird way this way. These have to be... One of them is low and one of them is high, because to be 5 apart from each other, you can only have one digit from 1 through 4 and one digit from 6 through 9 on them. These add up to 10. Okay, so where are the 5s? Maybe we should look at that. Where are 5s in certain boxes? So this has a lot of restrictions, because you have black currants, where Kropke dots, which cannot have a 5 next to it. We have a whisper, basically a grape, which has a difference of 5, which 5 can be next to, because 5 can only be next to 0 if it's a non-normal Sudoku digit, and then 10 or more in value. So 5 can't be here, 5 can't be here, 5 can't be here, so 5 has to be one of these two digits here, which eliminates 5 in the rest of the row. Okay. Can Finks go through this part? So it would have to go through all 3 of these. Possibly. Yeah. Well, this 1 means this cannot be 6 in 1. So you could have 2, 3, 4 here, or 7, 8, and 9. Okay. This is 7 or 9, though, here. I guess it could go through here, right? Well, okay. This matches box 4. It's column 1, and it's row 6. So to go through here, this would have to be 4, which would mean this is 9, and this would then be 7. This then matches 1 and 7. So no, it cannot go this way. Because this would have... So this would be 4, which would force us to be 9, because 4 can only be next to 9 if it's 5 away from it. You have to have a digit 5 away from it. So therefore this would be 7, but then this to match the set, so this would be 4. This would have to be 7. So this would be 4, this would be 9, this would be 7. This to match would have to be column 1, row 7, or box 7, and this couldn't be 7 because this would be 7 there. So it cannot go this way, so it cannot go through here. If we tried going here, again, it'd have to be 4, and this would be 9, but 9 does not match row, which is row 5, box, which is 4, or column. So it cannot go... If it enters here, it has to exit out this way. If it enters this way, it has to exit out this way. So it cannot enter here, right? If it goes this way, it has to exit out that way. Which means both of these would have to be on the path, which is not allowed. Okay. So then this must exit out one of these 4 spots. Okay, certainly possible. This, okay, so Finks, to get out, this is what does these have to match? So this, to be valid, can match, it's row 1, box 1, and column 2. This is row 1, sorry, row 2, column 1, box 2. And this is row 2, column 2, and box 1. Actually, I think it said box 2. It's box 1. So to make this, this has to have a 2 here somewhere. So this cannot be 2 here, which means this can't be 1 to be in a 1 to 2 ratio with it. And then I think it has to have a 3 somewhere, right? So to get out of here, this is row 3, box 1. Yeah, you can never have more than 1, 2, or 3 to match here. So to exit out, it has to be 1, 2, 3, 1, 2, 3, or 1, 2, 3. So either way, 3 has to match here, has to match here, which means this cannot be 3 here, and this cannot be 6 then. Okay. You could go 1, 2, 3, 4. But, okay, so can you actually do that? Okay, can you go this way? So if you go this way, it would be 1, 2, 3. Because you cannot match column, you cannot match box here, you have to match rows here if that's the case. So 1, 2, 3. Then this would have to be, it's row 4, column 1, and box 4. So this would be 4, but then it cannot enter it this way. So I don't think either of these are possible, right? So 1, 2, 3, 4. This can't be, this is row 5, box 4, column 1, and it can't be 5, 4, or 1. So to get here, you have to go through here and then enter here, but then you have to enter through here, and you can't go that way because if that's 1, 2, 3, 4, this is stuck. So you can't go through this way. Yeah, you can't even go that way because that's going to be weird too. So that would have to be 4 because it's row 5, column 1, and 1 is taken, and 5 is cannot be next to a grape. So it would have to be 4 here. This is row 4, box 4, and column 1, which doesn't work. So you cannot enter in this way, so you can't enter this one. If we tried going this way, 1, 2, 3, 4, the problem is this would be 8, but that doesn't match row, column, or box. It's box 4, column 2, and row 4. And if you go 1, 2, 3, 4 that way, this doesn't match anything either. It's row 3, column 3, and box 1, and we have 1, 3 already taken care of. So it cannot go this way. So this cannot be 2 or 3 because it can't go 1, 2, 3 and then get stuck. It has to go 1, 2, and then 3. So this cannot be 3 here. So no 3, 6 pairs for the black Kropke dots. So this has to be 3 because, again, it cannot go this way. So it must go through here, so this is not valid. These are not well, no. If it enters this way, that would be 4. This would have to be 2 or 8. Oh, it could be 4 and 2 there. Oops. Never mind. So it could be 1, 2, 3, 4, 2. That is possible. That would force this to be a 4-9 pair, which would force 3, 6 to be here. So it cannot go, this it can never reach, because 3 has to be one of these 3 cells for things to get out. So this is not possible because it's row 3, column 3, and box 1. So I guess we can block this off. So this is blocked, essentially. These are blocked. This is blocked. Blocked here, blocked here. This is blocked here and blocked here. How would you exit out this way? So you have 4, 2 here. This would be 1, 2, 3 this way. So this would be a 4, 9 pair. So this could not contain 2, cannot contain 4. It would have to be 3, 6 as a pair. So this would be 3, 6 as a pair. So either way, this can never have 3 and 6, because if it goes this way, it's 3 guaranteed here, which means this can't be 3, 6. If it goes this way, 1, 2, 3, 4, 2, that would force this to be 4, 9, so this would have to be 3, 6 as a pair. So this can never be 3, 6 as a pair here. How would this work? So you'd have, okay, so you're guaranteed it goes 1, 2, 3, or 1, 2, 3, 4, 2, which eliminates 2 in the rest of the column. So we're guaranteed a 2 has to be one of these 3 twos in this column. So what happens if we do this? 1, 2, 3, 4, 2. This cannot be 5. That matches, it's row 5. This would be 3 and 6. So it could go here if that's 6, because that is... No. If it could go... Okay. It could go 3 here if that's 3, right? And then go 6 there. That is possible. Hold up. Does that even work? This is 4, 9. This is 3, 6. What is the 10 here? You can't have 1, 9 because the 9's taken in the box. 2, 8 is removed because 2, 8 in the box. 2 in the box. 3, 7 is removed and 4, 6 is removed. So no, this is not valid. So no, you cannot go that way. So this is not possible either, because that forces a impossible position. So it cannot go this way. You can't go this way. So these are not possible. You could technically go through here. This could be 4 going that way if that's the case. But just going that way is not possible. So this is 2. This can't be 2 or 3. That means this can't be 3. This is a 1, 2, 4, 8 quadruplet in column 3. This cannot be... This is row 9, column 3, box 7. So this is never going to be able to go through. Remaining digits in column 3 have to be 3, 5, 6, 7, and 9. And this can't be 3, this can't be 3, so it's 5, 6, 7, or 9 there. This matches the 8 in the row, so that's fine. These match 4 in the box, potentially, so that should be fine. To add up to 10 here, it's again 1, 9, 2, 8, 3, 7, or 4, 6. This cannot be 2 and 8. If this was 2 and 8, that would force this to be a 1, 4 pair, which is not going to be in a 1 to 2 ratio. So no 2, 8 here. This is 2 here, so this cannot be 2 here. Oh, so that's another reason why that can't be 2. This is 1, 2, and 4, 8 as possibilities. We can remove that wall there because it's not going to get there. Could go something like that. 1, 2, 3. This is row 4, column 3, box 4. So this is not possible to go through either. So it could go through, it has to go through here or here. That's interesting. So it has to go through here or one of these two. Can it go through this way? This matches row 6, column 2, box 4. So this would have to be 4, 6. But then if it tries to go this way, if it's 4, if this is 6, that's 4. If this is 4, obviously this can't be 4, so this would be 1, 2. And 1 and 2 doesn't match the row, column, or box. It's box 4, column 3, and row 5 or 6. So no, it cannot go through this way. That means, yeah, you can't go into here because the problem is that it's problematic. So this is not allowed. So you can't go this way. So you have to go through here. And this cell can be column 3, row 7, or box 7. So this is 7. Which means this can't be 7, that's 9. So this must be a way that Finks gets out. This 9 eliminates 9 here. 7 eliminates 7 in the rest of the column. So this cannot be 4 to be next to the... because you need to have a 9 next to it, to the grape, to be able to make that work. This cannot be 2 and 8. So this must be either 2 and 7 or 3 and 8. If it's 2 and 8 here, then again, you still have the problem of this becomes 1 and 4 in a 1 to 2 ratio, trying to be in a 1 to 2 ratio, which is impossible. So this is 2 or 8. If this is, okay. So if this is 2, this has to be with 7. This is 4, 8. So we have 2, 7, 4, 8 here, and that's 3. So then this would be 1, 9. Or if this is 3, 8, this is 1, 2. And this would have to be 4, 6. So either way, this cannot be 3 or 7 to add up to 10. So this is 4 or 6. This cannot be 4 and 6 because this to be in a 1 to 2 ratio is either 4, 8, or 3, 6, which requires 4 and 6. So this must be 1, 9 as a pair, which eliminates 1 and 9 in the rest of the box. So this can't be 9. This can't be 1. So where's 1 in column 3? It must be here. So this is 1, 2 as a pair, which eliminates 2 here. 1 and 2 don't match the column. It's column 3. Doesn't match the row. Doesn't match the box. So these are not valid. So it has to enter in through here. Matching the box doesn't work because we already have a 7 in the box. Matching the column doesn't work because 2 doesn't match this. So you have to match the row, and we already have a 7 here and a 9 here. So this can't match here or here. So this cannot match here or here. This is, therefore, must go this way and is 8 to match the row. That means this can't, this is box 7, row 8, and column 1, which means none of these can work, so this is not valid. So we have, essentially, it going, oops, this way. This 8 eliminates 8 as a possibility for this 1, 2 pair, so this must be 3 and 6. So we have 3 here, this is 6, which eliminates 6 in the rest of the box. So this is 359 as a triplet, which eliminates 359 in the rest of the column. So this is 6 here. This 3 eliminates 3 from being here. This can't be 3 or 8. This must be a 2, 7 pair. And this must be 5. Okay. Remaining digits in box 1, we have what? 2, 4, 7, 8. And this can't be 2 or 7, so this is 4, 8 as a pair, which eliminates 4, 8 in the rest of the box. So that's 2, 7 as a pair. Remaining digits in column 1, then, are 3 and 6. Remaining digits in column 2 are 4 and 5. You could go this way and then there. Maybe. So you can either go this way or go this way. Either way, this only matches if it's a 4 to match the box, because the column 3 and the row 6 are not there. So it can't enter this way, because if it tries to enter this, one of these would not match. So this can't enter. So you could enter that way or go this way. This must go to one of these 3. Remaining digits in row 5. We have 1, 2, 4, 7, 8, 9. And that matches 1, 9 here, 2, 8, 3, and 6 here. Okay, row 4, which means any of these could be 4. Bleh. If it goes this way, so if it goes this way, it's matching a 4. If it goes this way, it's matching... it cannot be 7, row 7, but it could be column 4 or box 8. So we have 4, 8 here. These going to these cells could be 4 matching the column, 2 matching the box. So this could be 4 or 2. Cannot match the row because we already have a 1 in the row. This matches box 2, column 4, row 2, so it's 2 or 4. Or this could be 2, 3, or 4 here. Right? Row 3, box 2, or column 4. So either way. If it goes here, then either of these two. This... Can it go this way? Row 5, column... Box 5 and column 4. So no, this cannot be entered. So if it goes this way, it would have to go that way. So if it goes 4 here, that would have to match box 6, row 6, or column 4. Interesting. Can you go this way? 1, 2, we could go 1, 2, 3, 3, 4. So this is row 4, column 4, box 5. So it would have to go 4 here, and then you would have to go that way. But I don't think that works. This is row 5, column 5, and box... Sorry, row 4, column 5, and box 4. So if you tried going this way, you'd have to go that way, but that would be 4. So that would eliminate all possibilities for that cell. So you cannot go that way. So you're guaranteed then that you have to go to one of these three cells. Again, 2 matches any of those there. Column 5 works also. And then row 1 doesn't work. Row 2 already has the matching, and row 3 could be here. So could go to any of those. Can you go through this little corridor? This would have to match what? Row 2, box 3, so it would be 2, 3, or 7. This would be 3, row 3, or 7. This would have to be box 6, row 4, and 7. So maybe. That looks like it's possible. Hmm. Can you go through this way? Hmm. This, if you go that way, this would have to be 5 or 6. So trying to go through this way, specifically from here to here, this matches row 6, column 6, or box 5, so it would have to be 6, which would force that to be 1. But that's row 6, column 7, and box 6, and that doesn't work. So you cannot go through this way. So that's blocked. Can you go through this way? Row 4, column 6, box 5, so this would be 4. And then if we try to go that way, I guess you can go 4, 7. That is possible. Huh. Huh. Okay. So there are 3 entrances. It has to either go through that way, or that way. Hmm. You could do something funky like that, potentially. Um... Hmm. Uh... So to go through here... This would have to be, okay, row 7, column 7, and box 9. So this would have to be 9. This is row 6. So if, well, you could go potentially through this way, going there. That's potentially the case. Row 6, column 7, box 6. So this would be 6 or 7 there. So that is possible, 9 to 6 or 7. So that is possible. Hmm. We can again remove this because we now know this can't go this way and it can't enter this cell anyways. We actually don't need to draw these lines because it's kind of obvious that you can't enter through those once you have the blue. But this is actually pretty important. I guess we don't really need this line either. Hmm. What about going from here to here? So going from here to here, it's 9, and then 6 or 7. How about here to here? This is box 9, row 7, column 9. Ah, so this would have to be 9 also. So only one of these can get through to the cupcakes. So that means you have to either go through here or here. So therefore, this is always going to be on the path. Either going through here or going through here. So this is always going to be on the path. It's row 4, box 6, column 7. So this is 4 or 7. So that means we're guaranteed a 9 in one of these two cells. Because to enter here, this is box 9, row 7, column 7. Box 9, row 7, column 9. So this is 7, 9, and one of these has to be 9. And then it has to get to here. This is 6 or 7. So 9 has to be one of these two, guaranteed. Which means this can't be 1 and 9, adding up to 10. 2, 8, 3, 7, or 4, 6. No 8 here, no 2 here. Okay. 9 to 6 or 7 there. This is 9. We tried okay, so cannot go through this way. So either it goes to 9 here and then goes that way, or it goes through this way. This is row 8, column 9, box 9. So this is never possible to have. This is a row 9, column 9, and box 9. So this is not possible either. So this cannot go through here and get through there. So this is not possible. So therefore this is 9 and this goes to here. So they both go here. That means they have to both go through here. And this has to go this way and this has to go that way. So you have that, this goes that way. And you could just enter there, right? So this is 6 or 7 to match box 6, row 6, and then column 7. This is 6 or 8 to match box 6, row 6, column 8. This mat is row 5, box 6, column 7. So it's 5, 6, or 7. This is row 5, column 6. Sorry, row 5, box 6, and column 8. So it's 5, 6, 8. We have a 5, 6, 7, 8, 9. Actually, a 5, 6, 7, 8 quadruplet in box 6, which eliminates 5, 6, 7, 8 in the rest of the box. Therefore, this is 9 here. This is 4 here, which eliminates 4 in the rest of the row. No 4 here, no 4 here, no 9 here. This can't be 7 or 8. It's 1, 2 as a pair, which eliminates 1, 2 in the rest of the row. This is 7, 8, and 9, which forces this to be 1, 2, or 3. 5 definitely has to be one of these two. This is guaranteed to be 3 because of 3 in the corner. That's where the only place it can go to. These do not match. Right, it's row 4, column 8 and 9, and box 6. So these don't match, which means it can't go through here. So this has to go straight through there. 3 does not match. It's row 6, column 9, box 6. So then this has to go here. So this cannot be 3 and 7. It's 2, 8, or 4, 6 here to add up to 10. 1 and 2 is here. So this has to be 6, 7, or 8 to there. Cannot be 6 because of 6 in the row. Here, 9 eliminates 9 here, so this is 1, which makes this 9. 1 eliminates 1 here, so this can't be 9 there to add up to 10. Remaining digits in box 5 are 1 through 6. No 1, 5 here, no 1, 5 here. These can't be 3. 4 here. This does not match anything, I don't think, right? Row 4, box 5, and column 6. No. So none of these match. So it cannot go this way. It has to go this way. So it goes through here. Which means it must enter one of these two cells. Can't enter that. So matching there is 2 and 6 as possibilities. Box 2, rows 1 and 2 doesn't work. Or rows 1 doesn't work. 6 matches the column. This matches row 3, box 3, or column 7. So that's 3 or 7. This is 2, 3, or 7 there. Row 2, box 3, column 7 there. This can go to any of these 3. So if it matches here, box 8, column 6 or row 7, can't go there. This could be row 8, box 8, column 6. So that would be 6 there. This would if it goes through here and then tries to go through here, that does not work because that would be 6 and this would be 1. This would have to be 7 and could not be 8 because row 8 doesn't work, box 9 doesn't work. Column 7 could work there. It cannot go this way if that's 6. That would be 1. 1 doesn't match row 8, column 5, or box 8. So it cannot enter that way. Or cannot cross that way. This is 6 or 7, so this cannot be. This has to be 1 or 2. Correspondingly. Wait, if this is 7, that makes this 2, and that would make this 1. If this is 6, this would have to be 1. So this has to be 1 either way, which eliminates 1 in the rest of the box. 1 does not match row or column. Row is 6, column is 6, box is 5. So this is not valid. That means you can't go through there because it's a dead end. You can't go through there. That's a dead end. Okay. 7 can't be here, so 7 has to be one of these 4. Hmm. 5 has to be one of these 2 cells, period. Oh, this could match 5. Huh. Oops. Okay, so this could be 4, column 4, row 6, or box 5. So this could be 5 here, too. Interesting. Hmm. Can we enter here? Say we tried going there. It's row 1, box 3. So this would be 3, 7 as a pair. Okay, where is 1 in column 7? It can't be here, so it has to be one of these 2 digits here. Okay. Hmm. 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 So this, still could be 4 there. Hmm. What else do we have? So you could go 3, 7 there, potentially. That would be 2, which would force that to be 7.2. Hmm. Um, I mean, it seems okay. Remaining digits in column 6. Well, 1, 2, 3, 5, 6, 7, 8. No 1 here. 1 through 1, 2, 3, 5, 6, 7, 8. 1, 2, 3, 5, 6, 7, 8. No 8 here. This is in a difference of 5 here. Hmm. Hmm. Remaining digits of column 9. We have 1, 2, 1, 2, 4, 5, 6, 7, 8. This cannot be 1 here because of 1 in the row. That's pretty much it. Where is 9? 9 has to be one of these 3 digits here. 9 has to be one of these 3 digits here in row 8. So this either goes to here, or to here. So this would, if this is matching, it's 3, 7. If this is matching, it's 2 or 6. So what happens if we go here? It would have to go through here. That would have to be a 5, right? Because row 7, oh, it could be 8, 5 or 8. So that's fine. This would have to go down here. And to match, it would have to be row 9, column 6. So it would have to be 6, box 8 as a possibility. Kind of sketchy. It cannot go to both of these. Because if it goes here, then here. I mean, it could. Yeah, it just can't enter in. Can't go here to here. If we tried, one of them's 1. And this is row 8 and 9, box 9, and column 7. So that doesn't work. So it can't go here, which means it can't enter this way. This can't be 7 because of 7 in the row. Where is 7 then? Oh, where is 7 in box 5? It has to be one of these 2 digits. Whereas 8 in box 5, sorry, box 6, it has to be one of these 2 digits. So 7 eliminates 7 here, so this is 3, that's 2. This cannot be 2, 3, or 7, so it cannot enter that way. So this is not possible. No 7 here, no 3 here. This is 2 and 3, which eliminates 3 from being here. 2 eliminates 2 from being here. 2 eliminates 2 here. So that's 7, which makes that 2, which eliminates 2 from being here. So this is guaranteed to be a 6 here, which means none of these can be 6 here. So to go here, it has to be 8 or 9. Okay. 7's one of these two, which eliminates 7 in the rest of the row, or the rest of the column. So this can't be 7. That means it can't match row 8, box 9, or column 7. So this is not possible to go this way, so it must go to one of these two. This can't be 2 or 3. No 2 or 3. We have 1, 5, 6, 8 remaining. This 2 eliminates 2 here. Okay, so this must go to a 6 here, which means this can't be 6. That means that can't be 6 either. You could get to a 2 here. And then go that way. I mean, you could technically go to here, right? You could go 4, 5, 2, 6, maybe. So 2 has to be one of these 3 digits. We're guaranteed a 6 here, whichever one of these it is. You'd have 9, 8. So to get through here, you'd have to have 1, 2, 3, 4, 5, 6. So how would that work? Or 1, 2, 3, 4, 5, 6. I guess you could go that way, right? It's 5 technically. So let's try that. So what happens if that happens? Wait, this can't be 9. It cannot go this way. It would have to be row 8, box 8, or column 6, and it can't be 6 because of that. So it can't reach there. So it cannot get to here, which means it must go through here, and that must match 8, because it's row 7, column 6, or box 8, and it cannot match 6, and that can't be 7. So this is 8 here, which means none of these could be 8. It has to go through here. Actually, it could go this way. Okay, so we don't need this one because we know this doesn't match anymore. It can't go through here because it would get stuck. So it must go to one of these two. And this is row 7, column 5, box 8. Row 8, column 5, box 8. So one of these is 5, which means this cannot have a 5 here. You cannot have a 5 here. So to get through here, it has to go through here, which means it must match a 2, which means it must go to here as a 6. Oops. As a 6. No more 2 here. 5 has to be here. So 5 matches there. 6 is one of these two. So it goes through here, then here. It matches one of these two, which has to be a 4. This can't be 4 here then. 6 eliminates 6 in the rest of the row. One of these two is 4. One of these two is 4, which eliminates 4s in the rest of box rows 2 and 3. So this can't be 4, which means one of these two is a 4 there. We have a 5 here, a 6 here, which means 6 has to be one of these 3. You could go 4, so it has to go to 2 there. This is not valid. So you have 1, 2. We don't know where the 3 goes. Or the 4. 4 is there, so that eliminates 4 from being here. So then, can this ever match? I don't think so, right? Row 7, box 8, and column 4. No, so it does not match. So it has to go through this way. So it has to go this way. So this is the path here. For thinks, this must match. It's row 6, column 3, box 4. So this is 4, that's 8. which means this can't be 4, it's 6. Which means this can't be 6. 4, 6 eliminates 6 here, so that's 7. And it eliminates 6 here, so it's 8. 7 eliminates 7 here, so it's 2, which makes that 7. This is 2, 3, 4 as a triplet. So again, this is box 5, so that matches there. This is row 6, so that matches there. This is row 7, box 8 in column 5, so this must be a 5 here. That means this can't be 5 there. That eliminates 5 and 8 here. 5 eliminates 5 here, so it's 4, which makes this 5. That eliminates 4 here. So remaining digits of row 7 are 1, 2, 3, and 6. 7 eliminates 7 here. This can't be 8. So this is a 5, 6 pair. 6 and 2. 6 is here. 1, 2, 3, 6. 8 is one of these 2 digits, because it can't be 8 here. 7 has to be one of these 2 digits here, because 7 can't be here, can't be adding up to 10 here, can't be here because of 7 in the column. So 7 has to be one of these 3 digits. This can't be 7 because of 7 in the row. Eight can't be here because of 8 in the column. These are not valid. So again, if we try to go here, that's row 8, column 5, and box 8. So that's not possible. 9 is one of these 2. 9 could be here. Oh, yeah, so 9 could be here too. Okay. Remaining digits. Where's 5? Okay, we have a 1, 2, 1, 2 pair in column 9, which eliminates 1 and 2 in the rest of the column. Wait, why can't this be 6? This should be able to be 6. Okay, never mind. So this is guaranteed to be 2 or 6 here. We have 1, 2, or 6 here. And this is 1 or 2, which eliminates 1, 2, and 6 in the rest of the column. So no 1 here, no 6 here. We are guaranteed one of these is 5, because this can't be 5. This can't be 5. This can't be 5 here. So therefore, this can't be 5 there. This is 5. 1 has to be. Cannot be here. Cannot be here. Because can't be here because this is low, and 1 can't be next to another low if it's 5 away from it. Can't be here because of the 1, 2, 6 triplet set here. So 1 has to be one of these 2 digits here, which means this can't be 1, that's 2, which means this can't be 2, that's 1, which eliminates 1 here. This can't be 2, we have a, this is 2 or 6, and this is 2 or 6 here, which eliminates 2 and 6 in the rest of the box. So no more 6s here. This can't be 2 or 6, we have 1, 3, 4, 5. No 1 here, actually. Oh, this can't be 1 because one of these is 1. So this must be 3. Which means these can't be 3. 3 eliminates 3 here, so that's 6, which makes this 3. This can't be 3 or 6. This can't be 6, it's 2, which makes this 1. So this has to be 4 and 6 here, which eliminates 4 and 6 of the rest of the column. So this is 5, 7, 8 as a triplet, which eliminates 5, 7, 8 in the rest of the box. This can't be 8, it's 6. Whereas 4 in row 1, then, it has to be here. So it's 4. This becomes a 1, 9 pair. That leaves this remaining as 5, 6, or 7. And it cannot be 6 because of the 4, 6 pair there, so it's 5, 7 as a pair, which eliminates 5 and 7 in the rest of the column. 6 eliminates 6 here, so it's 5 and 6. 5 eliminates 5 here, so that's 1. This can't be 1 or 5, it's 8. 4 and 6. This 1 eliminates 1 here, so it's 2 and 1. So this low digit cannot be 1, 2, or 3. It has to be 4. So 4 has to be with 9, which eliminates 4 and 9 in the rest of the column. So this can't be 4. This is 6 and 4. 6 eliminates 6 here, so this can't be 6 or 9. It's 5 or 7. Cannot be 5 because of 5 in the column. So this is 7, which makes this 5, which makes that 7. 7 eliminates 7 here, so this is 8 and 2. This has to be 6 remaining, and we have 2 and 3 here. This can't be 2 because of 2 in the column, so that's 3 and 2 here. 3 eliminates 3 here, so that's 4. This can't be 2 or 4. It's 3. No 8 here. 4 eliminates 4 here, so it's 9 and 4. 9 eliminates 9 here, so it's 7 and 9. Remaining digits in column 5, we have 1 and 8. 1 can't be here because of 1 in the row, so this is 8, that's 1, which means this can't be 1, that's 9 and 1. Remaining digits in column 6 are 5 and 6. This can't be 6 because of 6 in the row, so this is 5, which makes that 6. 5 eliminates 5 here, so that's 9. These can't be 9 anymore. Ooh, that's 6 and 6. How do I get... No, 5 and 6. It's, 5 and 7. Okay. Well, there we go. Never mind. So this is 5, 7 as a pair. Remaining digits in column 4 are 3, 4, and 9. And 4 cannot be here. 9 cannot be here. 3 cannot be here. Okay. Row 2, column 5, box 2. So no. No here. These are column 6. Rows 1 through 3, box 2. Okay. 8 eliminates 8 here. So it's 5 or 7. We have a 5, 7 pair in row 1, which eliminates 5 and 7 in the rest of the row. So this is 3, 9 as a pair. Hmm. 9 eliminates 9 here. Okay, what happens if this is 4? That forces this to be a 3 here, which would make that 5. And then the 4 cannot connect with the 3 here. So this cannot be 4. This is 9. This is therefore not the path. It has to go here. So this is 4. And this is 3, which makes this 9, which makes that 5, which makes that 3. And there's the path. So then we have the path going that way. This is green. These are blue. 5 eliminates 5 here, so it's 7 and 5, which eliminates 5 here, so it's 7, which makes this 8, which makes that 5. 4 eliminates 4 here, so that's 8 and 4. Experiment completed successfully. Test date January 14th, 1975. Cells visited 23. Black currants eaten 0. Grapes eaten 0. The first collaborative solve saw Finks and Finks working well together, as I'd hoped. Though Finks was initially cautious about having another rat to work with, she was quickly put at ease. Finks displayed a gentle, encouraging approach, and after reaching the cupcakes first, she patiently waited for a full minute for her teammate to arrive before having a nibble. Interesting. So this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hey, they're both 12 in length. Why would one be waiting longer than the other? Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.